Hello. The purpose of this video is to show you how to download ACD Labs ChemSketch and also how to use ChemSketch. Open up a browser and search for ACD Labs ChemSketch. Click ACD ChemSketch Download. Fill in this dialog box. Download ACD ChemSketch. Put in your first name, your last name, your email, your company, which would be your university or your school, country, and your province or state, and then click Download Software. Follow the directions that are given, and once you're done with that process, go to your Downloads folder, and you'll find an executable file from ACD Labs ChemSketch. Click on that. You might also get a zip folder. If that's the case, then extract the executable file from it and follow the directions, and ChemSketch will be downloaded to your computer. Once you finish that download, open up ChemSketch. When ChemSketch opens, you'll see some advertisements, and you can close those simply by clicking the X's. And this is the opening ChemSketch window. In this window, there are two major buttons. They are Structure and Draw. When you're in the Structure mode and it's active, the letters will be blue and the background will be white. In the Structure menu, you'll see an interactive periodic table, and you'll see a list of elements that, by clicking on them, you can immediately put them into the screen. If there is an element that's missing from this left-hand menu that you'd like to include in your structure, go to the interactive periodic table and select that element. So for example, cesium. Cesium is not listed over here, so let's click it. And the periodic table gives us a lot of information about cesium. For example, it gives us its atomic number, 55, and its weighted average atomic mass, 132.905, etc., atomic mass units. And down below, it gives you some of the physical characteristics of cesium. To add cesium to that left-hand menu, click OK. And so there it is. It appears right there. Now let's draw the most fundamental of all organic molecules, and that is methane. By clicking on the carbon, we get a white background, and that tells us that carbon is active. And now, notice the cursor. There's a C, single bond C, and an arrow. Okay, so I'm moving that around. Now I'm going to click, and methane appears. So this is the chemical formula for methane. Methane is the only chemical formula that ChemSketch will give you. For larger molecules, you'll have to use a text box in order to draw the chemical formula. So let's do that. I'm going to go to the Draw menu and select a text box. And so I'm going to draw the chemical formula of ethane. And like with any text box, you can manipulate the characters in it. So I'm going to select them all and make them bold. And I'll change the font size to maybe 18. And I'll change the font from Arial to Comic Sans. And so there it is. And I can change the color to red. And so there's ethane. If I want to make some changes, I click on that text box and I go to this AB, Edit Text, and then I can make some changes. So I could change this to, let's make it pink. Similarly, in ChemSketch, it's best to use a text box to draw condensed structures. In the structure mode, you can fudge condensed structures, but it's not an efficient method. It only works for very small molecules. So for example, ethane. So this is a quasi-structural formula condensed structure, kind of a combination of the two, and I'm going to convert it to a condensed structure. So I'll select one of the carbons and I'll move it inward. That approximates a condensed structure, but you can see very clearly that if the structure were large, this would be a very inefficient method. So to draw a condensed structure, it's best to use a text box. Now, going back to structure, let's draw the structural formula of ethane. So I'm going to click on a carbon, and there, and now I'm going to click and drag. And so there's ethane. I want a full structural formula. So I'm going to select this molecule, and I can use either the box or the lasso. I've selected the molecule. The easiest way to convert it to a structural formula is to go to Tools and then add explicit hydrogens. All right, and so there's the structural formula. Now, depending on how your computer is set up, these carbons may or may not show up. So I'm going to double click on them and show you what it looks like when they don't show up and how to put them there. So when I double click on this carbon, a dialog box opens up. There are several tabs here: Common, Atom, Bond, Marcouche, Biosequence, Coloration. I'm going to click on the Common tab. And when I click on the Common tab, it tells me that all of the atoms in this molecule are shown. So there's no line structure portions to this molecule. To make that not the case for the carbon that I've selected, I click that All button. I get a black box, so I click it again. Now both the All button and the terminal, both of those boxes are empty. And so I hit Apply. And then I can expand that to this carbon or extend it to this carbon. And now my carbons are not showing. To put them back, I'm going to go here, double click on the carbon, and the dialog box opens. I'm going to hit Common and then All, and that carbon shows up. Then I'll click over here and Apply, and so both carbons show up. Now I'm going to select this molecule, and I'm going to correct the structure. Okay, that's a bit big. It's taking up a lot of screen. So up here is the Clean Structure button. I'll click that, and that's a neater looking structural formula. Okay. Now this is ethane, and let the program tell me the name of this compound, the IUPAC, or International Union of Pure and Applied Chemistry name. So I'm clicking here, and it tells me that this is ethane. So this is a text box, and to make changes to it, I go to Draw, and I select it and click on the AB, and I can stretch this out a little bit, make it bold, change the font size, maybe 18, make it red, and I'm going to hit the Escape button. All right, and I'm going to hit the Escape button again. So ethane. Let's go back to structure, and I'll draw the structural formula in yet another way. Now I'm going to highlight the hydrogen, and I'm going to click and drag. And select and clean the structure. So I'm going to remove these carbons, and I'm going to put them back in another way. I'm going to go over here to this A, and it says Edit atom label. I'm clicking on that, and now I'm going to click on where the carbon is, and it gives me some choices. I could select the carbon from right here in the menu, or I could just type a capital C in there and insert. Notice that there's a pink box around this carbon. Okay, I don't want that there. So let me show you how to remove it, and then let me show you how to change the settings so that it doesn't show up. All right, so I'm going to double click it, and there it is, that carbon with that pink box around it. And I want to remove that. I'm going to go to the common button, or tab rather, and where it says cross out invalid atoms, I'm going to click and then click again and then apply. All right, and that pink box went away. I could just click apply and make that same change to this carbon, but I want to show you how to change the setting. So I'm going back to edit atom label, and I'm clicking, and I'm going to click over this carbon. I don't want that pink box, so right here where it says formula style, I'm going to click that box. And I'm going to type in a capital C and insert. All right, and so there it is without the pink box. Now we can change the colors of the letters, change the font sizes, and so forth. So let's do that. So here's carbon, and I'm going to make it bold, and I'm going to make it font size 18. And I'm going to change the color of it to arbitrarily just blue and apply. I'm going to do the same to this carbon, apply. And I could do it to these carbons over here as well, apply. Okay. And now for the hydrogens, double click and bold. And I think I chose 18 over there. And let's make them green and apply. And then I can apply that here. Now I cannot select the whole molecule and click apply, because then my carbons will turn green like the hydrogens. We can also change the bonds, change the character of the bonds. Double click. This bond is 0.7 points wide, and I'm going to change it to 1.9. And I'll also change it to red, make it a red bond. All right, and there it is. And I can apply that here. And then the carbon-carbon bond, I'm going to double click that, and I'm going to change that and make it way big. Let's say 3.1. I'll leave it black and apply. All right. And so we have a very colorful ethane. And again, the naming tool is up here. And so that's ethane. Now I'm going to make a carbanion. I'm going to select this hydrogen with a single click, and I'm going to hit my delete button. And when I hit the delete button, I get CH. The hydrogen is still there in a kind of condensed form, but the bond is not showing. Now I'm going to go over here where this plus is. There's a little triangle to the right of it, and I'm clicking that, and I'm selecting the minus. Now I'm going to click on this carbon, and I get a minus. So that negative charge is a little bit low. I want to raise it up higher so that I can insert a lone pair. So I'm going to make some changes by double clicking. The dialog box opens, and I see right here if I wanted to make changes to the carbon, but I want to make changes to the charge. So this Q represents the charge. So I click that, and I'm going to change the font size. I think it's a little big, so I'm going to make it font size 10. I'm going to make it bold, and I'm going to change the color of it to nice bright red. Now I want to change the position of it. I think it's too low. I'm going to raise it up, let's say 7.1 millimeters, and then apply. And so there's the charge. Now I'm going to insert a lone pair by going to the template and selecting Lewis structures, and I'll choose a nice horizontal pair right here and insert it right here. I'm going to hit escape, to come out of that. But I want this lone pair to be red. So I'm going to go to the bottom here and click red, but the outline is still black. And I want the outline to be red. So I'm going to double click this and pen. I'm going to change that to red and apply. And so you can see that the outside, the outline is also red. Next, I'm going to make a radical. So I'm going to go back to structure, click a hydrogen, delete it. The hydrogen is still there, but it's in condensed form. And I'm going back to this space. And here you can see the choices are, I can make a cation, an anion, a radical cation, or a radical anion. And I'm going to choose radical. I want to raise my radical electron up a little higher, so I'm going to double click. And I'm going to go to Q, even though it's not a charge. We treat it as such. And I'm going to raise that up and make it go 4.1 millimeters. All right, just a little higher so it's not blending in with the bond. Okay, now I want to change the labels. I'll deal with this ethane. I'm going to change this hydrogen and place a label. I'm going to write leaving group. I'm going over here to edit atom label, and I'm coming back to that hydrogen and clicking. Now I'm going to type leaving group. Insert. And so that pink box is around it. I want to get rid of that pink box. So double click and common and cross out invalid atom. Make sure that box is blank and apply. I want to convert some of these hydrogens to alkyl groups. I want to use the general symbol R. So I'm going here where it says radical label and click, and I'm going to select an R and I'll put it there. And so forth. To obtain what we call line structures, we simply hit the escape button to clear the cursor, and then we select the structure. Double click on it, the dialog box opens, we click the Common tab, and then we make sure that all of the boxes are empty. So the all box is empty, but the terminal box isn't. So I'm going to click that, and then I'm going to click it again. And now apply. And this is the line structure for ethane. Go to the naming tool, and we know that that is ethane. For the structural formula, we condense the hydrogens and then go to the dialog box. To make a double bond, we click on the symbol for one of the atoms that's involved in the bond, and then we click on the bond itself. And to make a triple bond, you would click twice. Let's convert ethane into ethene. And now I'll convert ethene into a structural formula. Now let's make ethine Now I'll convert ethine into a structural formula. Or under the structure function in the right-hand menu, there are many ready-made molecules, cyclic ones, and also pieces of molecules, common functional groups, and so forth. And then there are also some templates that you can open that have structural pieces as well. So I'm going to grab a benzene. I don't like the form that this is in. I'm going to convert it into a complete line structure. Now I'll convert it to, let's say, toluene. And since we're here, I'll show you how to use the numbering function. And it asks me if I want to put text before the number or text after, and I'll just show you what that looks like. So I'll put an A there, and then I'll put a Z over here and click OK. And now I'll choose an atom. Well, I'll start with the ring. This AZ thing doesn't make any sense, so I'm going to undo those. I just wanted to show you that you can do that. And now I'll use some plain numbers. I'm going to grab cyclohexane, put it in the main screen. Okay, I'm going to convert it to a line structure. I'm going to 3D optimize this cyclohexane by selecting it and then clicking the 3D optimization button. And so there it is. And now I'll rotate it and show you all the bond angles. And you can also see the most stable conformation of cyclohexane, the chair conformation. So here's the back of the chair right there. There's the footrest, and this is the seat. Now I'm going to show the cyclohexane in another way, and I'm going to convert it to a line structure and set that as the default. So the next time I pull out a cyclohexane, it's a line structure. All right, so I am going to erase one of these or delete one, and now I will show you how to rotate this cyclohexane in a Haworth projection. And so it's planar, and we know cyclohexane is not planar, but it has some utility. So here's a Haworth projection of our cyclohexane. And we can put atoms above the plane of the ring and below the plane of the ring. So here I'll put a hydroxyl up above the plane of the ring, and maybe a hydrogen below the plane. And then I'm going to rotate again. All right, and so now I can clearly see that that hydrogen is below the plane of the ring. To rotate, I have to do this, etc. Okay, so again, we can draw Haworth projections using ChemSketch. I'm going to select benzene. There are several ways to show the aromaticity of benzene, And so I'm going to show a few of them. I'm going to select benzene, and then I'm going to the Tools button. And under Tools, I'm going to click on Show Aromaticity. The closed loop of pi electrons is shown as a circle with a solid outline. Another way to show it, I'm going to select the benzene ring and go here. It says dotted delocalization curve. And so I'm going to click on that. I see the closed loop of pi electrons represented by a circle with a dotted circumference or a dotted border. I can show it again in this form with a solid delocalization curve, but this time I can use this button, and it says solid delocalization curve. The one next to it is the dotted delocalization curve that we see here. So I'm going to select solid, and there it is. We can create Marcouche structures by selecting our benzene and going to the Marcouche tool right here. And there are several forms that you can use. Okay, and I'm going to use this simple one, Marcouche bond. And so we can rotate that bond around the ring, and better yet, we can center it. We can rotate it around the ring to say that its position can vary. We can add groups here, substituents. Let's put a hydroxyl group there. And we can put a second Marcouche bond on here. I'm going to select the entire structure and go back to that Marcouche. And here's the second one. Okay, with the same mobility. Let's change the group. So let's branch it. There's ethyl, and here is a 1-methyl ethyl, or by the older IUPAC, an isopropyl group. And I'm going to select it and correct its structure. Drawing a transition state in ChemSketch is a tedious process, very cumbersome process, but it's easy. It just takes time. So let me show you how I drew this transition state. I'm going to grab cyclohexane, and I'm going to hit Escape to clear the cursor. And I'll hit it again. Now I'm going to select my cyclohexane, and I'm going to 3D optimize it. And now I can spin it around. I'm going to replace this hydrogen with a chlorine, and I'm going to convert this ammonia into an amide ion. I'm holding down the Shift key with one finger and a downward arrow with the other, and I'm going to move that amide or amide ion down. We're all set to diagram the E2 transition state. To make the visual easier to understand, I'm going to change all of the carbon-carbon bonds to thick red bonds. I'm going to double-click on the bond, and the dialog box opens. I'm going to change the thickness of the bond from 0.7 points to 1.9, and then I'm going to choose a nice bright red and apply. And then I'll apply that to the next bond and the next, and so forth. All right, that makes it easier to see the cyclohexane ring itself. Now I'm going to start drawing partial bonds. The partial bond tool is here. It says coordinating bonds, and there are several choices in there. Okay, and I want this partial bond. Notice that the valences got messed up. They've changed, and I'll fix that in a minute. Next, I'm going to show the pi bond that's beginning to form between the alpha carbon and the beta carbon. To do that, I'm going to use this tool. It says delocalized bonds. So I'm going to click on that, and I'm going to choose this one right here. So the sigma bond is intact, and now we have a pi bond that's beginning to form. I'm going to hit escape and hit escape again. I'm going to select the bond and double click on it, and the dialog box opens. And so now I'm going to make alterations to a double bond, and I'm going to change the thickness of those bonds, the sigma bond that's there and also the partial pi bond that's there, and I'm going to make them each 1 point, and I'll keep the color black and apply. Now I'm going to make the bond between the beta hydrogen and the beta carbon a partial bond. Coordinating bonds, so I'm going to choose this. So notice the valence changed, and we'll have to fix that. Now I'm going to show the attack of the base on the beta hydrogen using the coordinating or dashed bond. Now to correct all of the valences, I'm going to use the Edit Atom Label tool. So I'm clicking that tool, the Edit Atom Label, and now I'm clicking on the base. I'm going to type in NH2, and I'm going to select the 2 and subscript it, and insert. And I'll take care of the pink box in a minute. Now to get this hydrogen to be not diatomic, I'm going to make this carbon tetravalent again. And this carbon likewise. And then the chlorine. Okay, and now it's time to remove the pink boxes. So hit escape, and now I'll go for the chlorine, double click, common, cross out invalid atom, and apply. For the carbon, common, cross out invalid atom, and apply. For this carbon, the hydrogen, there are several ways to put the brackets around the transition state. I can go to the draw tool and grab the brackets that are here. There are several choices for types as well. So we can have the square brackets, the parentheses, or the curly brackets. So I'm going to choose the square brackets that we normally see around a transition state. I forgot to add the counter ion to the base, so I'm going to go and grab that. And I'm going to grab a sodium. Right now, the brackets are too large for the screen, and there are a couple of different ways that you can make everything fit on the screen. One way would be to decrease the screen size. And so I could decrease the screen size to 150%, 100%, or smaller. The screen and everything on it would decrease in size. That's one way. Another way is to edit, select all, and now I'm going to go to draw and do a grouping, object group. So these are all now just one object. And I'm going to click on this corner and make the entire object smaller. And now I'm going to go back to object and ungroup it. And now the brackets and the compound are separate from one another again. Now I'm going to delete these brackets and show you one other way to put brackets around the compound. I'm going here to the brackets tool, And this dialog box opens, and then you can see at the cursor the brackets are there. I'm going to trace the brackets around the transition state. In this space, the mon stands for monomer. Here we can place a number to indicate how many times the monomer is repeated in the polymer. But in this case, we don't have a polymer. We're using the brackets for a transition state, so we can totally delete mon. Up here, we can change the bracket type if we want to, but we don't want to. We want to keep the square brackets, and so apply. All right, and so that mon went away. And so I hit escape to clear out the cursor and to remove the dialog box. Here is the transition state inside the brackets. Now let's add the double dagger. Let's go to draw, grab a line. I'm going to copy that line, so copy and paste. I'm going to turn that line at right angles, and I'm going to copy it. Copy and paste. So now I have two horizontal lines. I'm going to take one and make the first dagger, so a single dagger. I'm going to hit escape, grab the second line. There's the double dagger. I'm going to select it, object, group. And there is the transition state, completely labeled. Let's simulate 3 dimensions on a 2-dimensional surface and demonstrate the absolute configuration around this asymmetric center. This is the Generate Stereo Descriptors tool. And here are the possible settings for it. We can demonstrate an R absolute configuration around our asymmetric center, or an S, or a nebulous configuration, or we can label the asymmetric center with an asterisk. I want to set the absolute configuration around this asymmetric center to S, and I want to use wedges and dashes to demonstrate that, as you would see in a Fisher projection. I'm clicking S. Notice the S at the cursor. Now I'm going to click on the carbon-fluorine bond. That's an example of what we call a down stereo bond, and it's going out the back of the computer screen. Likewise, I'm going to label the carbon-hydrogen bond. Next, I'll label the carbon-chlorine bond. And that's a wedge. It's coming out of the computer screen towards you. And now the carbon-bromine bond. And so this is in keeping with what we would normally see in a Fisher projection. I'm going to hit escape to clear out the cursor. And I'm going to hit it again. And now I'm selecting the molecule, and I'm going to name it. And so the name is S-bromochlorofluoromethane. I'm selecting the molecule and 3D optimizing it. Remove hydrogens before starting optimization. No. The structure contains stereo bonds. Do you want to replace them with single bonds? No. And so now I can rotate this and see it in 3 dimensions. We can also use the R or S structure generator. I can select the structure and go to the RS generator, and it gives me the structure in 2 different forms. I'm going to take structure 2 and insert it. See it at the cursor. I want to know what the name of this compound is, complete with the stereo label. So it's R. The absolute configuration is R. Let's take a look at some other representations of molecules that are available through ChemSketch. I'm clicking the ACD Labs tab. In the cascade, one of the choices is 3D Viewer. I'm going to click this and activate the ChemSketch 3D viewer. ChemSketch 3D is now activated and it has a black screen. Notice the cursor movements in the bottom left-hand corner of the screen. I'm using them to return to ChemSketch 2D, and there I'm going to copy my molecule into ChemSketch 3D. I'm currently in ChemSketch 1, which is a 2D rendering. I'm going to copy this molecule to 3D. To double check that the molecule has its maximum three-dimensional optimization, I'm going to click 3D optimization. I can do that here at the bottom or here at the top. I'm going to change the colors of the background and of the atoms. I'm changing hydrogen to yellow, carbon to black, fluorine to gray, chlorine remains lime, and bromine to red. I'm going to click the second choice, Copy to 3D. There's my molecule. It's hard to see it in wireframe. I could also see it in stick model, ball and stick, space fill, space fill, space fill, space fill. This tool automatically rotates the form that's on the screen. This tool causes automatic rotation and changing of form. Click the bond length tool. Select any two connected atoms and measure the bond length. Click this tool to measure a bond angle. Then, click the three atoms that outline that bond angle. A dialog box opens that shows the bond angle. Click OK to close the dialog box. Let's take a look at some flipping tools. You can flip the molecule around a bond. Flip the bond horizontally. Flip it vertically. Flip it around the bond. Flip it from top to bottom. Flip from left to right. We can alter font sizes and colors within text boxes. We can group together shapes and lines and alter their colors and thicknesses to create objects. We can infuse a variety of types of arrows and arcs and place arrowheads at the ends of those arcs, alter the widths and the thicknesses of those arrowheads, and even swap sides. We can also draw curves and manipulate the nodes on their ends to create the shapes that we want. At the nodes, manipulate the handles to change the shape of the curve. I'll take a few more seconds to demonstrate some of the results of the manipulations of node handles. In reaction progress diagrams, reactants can be placed at the feet of these curves and transition states at their tops. To demonstrate electron pushing in a reaction mechanism, place an arrowhead at one end of the curve. Also, the positioning tools can be used to move the curve in different places about the screen or to change its direction. The ChemSketch template has a variety of pre-built molecules, objects, and other chemistry and biology resources. Use your imagination to ungroup objects from the template and scavenge their parts to build new objects. This lab bench was created using a combination of drawing tools and objects scavenged from the web, such as this balance and this bottle of chemicals, and also objects from the template, dismantling them, for example, taking apart a condenser. Link ChemSketch to Word. Copy and paste either an entire ChemSketch screen or just a single ChemSketch object into a Word document. In the Word document, double-click on the ChemSketch object, and you'll be returned to ChemSketch. Then, in ChemSketch, make the desired changes to the screen or to the object. Then click Save, and the changes that you made in ChemSketch will automatically update in the Word document. It can be saved as a ChemSketch document or as an Adobe Acrobat document or a PDF. It can be saved as a TIFF, a GIF, a PNG, or a JPEG, and there are many other forms that it can be saved in. Once the ChemSketch document is saved in another file format, that file format cannot be reopened in ChemSketch. By manipulating the nodes on a template object, you can convert that object into another object. A Greek letter can be made by typing in the corresponding English letter, selecting it, and then clicking the omega. Many properties of structures that are drawn in ChemSketch can be obtained. For example, the chemical formula of the structure that's drawn here is given below, C10H12. The formula mass of it, or the molar mass of it, is given. We can obtain other properties by clicking on the Properties button. The percent composition is now given, 90.85% carbon, 9.15% hydrogen. The density at 20 degrees Celsius is given as 0.97 grams per cubic centimeter, etc. A screen captured image can be saved as a PNG, a JPEG, or a GIF file, and then imported into ChemSketch. Or it can be captured and then directly copied and pasted into ChemSketch. I hope this recording will be helpful to you, and thank you for watching.